Hi, in this video I want to explain about determination of Fourier constants. Before that let me introduce myself. This is K. Pawan Kumar from EEE B section. Determination of Fourier constants. This theorem states that any complex periodic function f of t can be expressed as a sum of sine and cosine in the form V is given by y equals to f of t equals to a naught plus a1 cos omega t plus a2 cos 2 omega 2 plus and so on an cos n omega t plus b1 sin omega t plus b2 sin 2 omega t plus and so on bn sin n omega t. By applying summation, this equation will becomes y equals to f of t equals to a naught t plus summation n equals to 1 to infinity an cos n omega t plus summation n equals to 1 to infinity bn sin n omega t. The expansion of the function f of t in the above form is known as Fourier series. Here a0, an and bn are the Fourier coefficients. So firstly determine the constant a0. By integrating equation 1 on both sides between the limits 0 to 2, we get the value of a0. See the derivation. By applying integration, the equation will becomes integral of 0 to t e f of t dt is equals to integral of 0 to t a0 plus summation n equals to 1 to infinity an cos n omega t plus summation n equals to 1 to infinity bn sin n omega t into dt. This equation will becomes integral of 0 to t f of t into dt is equals to a0 is constant, so we can write the outside of the integral, and remaining we can integrate integral 0 to t into dt plus summation and an are constant here, so we can write them outside of the integral. Summation n equals to 1 to infinity an into integral of 0 to t cos n omega t dt plus summation n equals to 1 to infinity bn integral of 0 to t sin n omega t dt. Here integral of 0 to t cos n omega t dt will becomes 0 and integral of 0 to t sin n omega t dt is also becomes 0. So the above equation will becomes integral of 0 to 2 f of t dt is equals to a0 into t. From this equation we can write a0 value. A0 is equals to 1 by t into integral of 0 to t f of t into dt. And the second one is determination of constant an. Multiplying the equation 1 on both sides with cos m omega t and integrate between the limits 0 to t. Then the equation will becomes integral of 0 to t f of t cos m omega t dt is equals to a0 integral of 0 to t cos m omega t dt plus summation n equals to 1 to infinity an cos m omega t cos n omega t dt plus summation n equals to 1 to infinity bn integral of 0 to t cos m omega t sin n omega t dt. So here integral of 0 to t cos m omega t dt will becomes 0 and integral of 0 to t cos m omega t cos n omega t dt has two conditions. If m is not equals to n is equals to 0, if m equals to n t by 2, and integral of 0 to t cos m omega t sin n omega t dt is equals to 0, and the above equation will becomes after substituting these values on the above equations, it will becomes integral of 0 to t f of t cos m omega t dt is equals to an into t by 2. So from this equation we can write an value. An is equals to 2 by 2 integral of 0 to t f of t cos m omega t dt, and the last constant determination of constant bn, and multiplying equation 1 on both sides with sin m omega t and integrating between the limits 0 to 2. So it will becomes the equation 1 integral of 0 to 2 f of t sin m omega t dt is equals to a naught integral of 0 to t sin m omega t dt plus summation n equals to 1 to infinity a n integral of 0 to t sin n omega t cos m omega t dt plus summation n equals to 1 to infinity bn integral of 0 to t sin m omega t sin n omega t dt. So here integral of 0 to t sin m omega t dt will become 0 and integral of 0 to t sin n omega t cos n omega t dt is equals to 0 and the integral of 0 to t sin m omega t sin n omega t dt will becomes 0 when m is not equals to n and it becomes t by 2 when m is equals to n. So the above equation will becomes integral of 0 to t f of t sin m omega t dt plus bn into t by 2. So from this equation we can write the bn value. Bn value is equals to 2 by t integral of 0 to t f of t. So this is the process to determine the Fourier coefficients a naught, an, bn. Thank